Deep in the cramped pantries, basements, and attics of most homes sits a heavy, pressurized tank of water. Out of sight and rarely maintained, the traditional water heater usually only gets attention when the bottom rusts out and water starts to pool on the floorboards. For decades, these units have relied on standard electrical resistance technology. It is a brute force method of heating water that draws a massive amount of power, often without the homeowner realizing how much it contributes to their monthly utility expenses. Because the core blueprints for these tanks have remained unchanged for decades, they remain susceptible to the same physical failures. Over time, the inner lining corrodes, or high pressure levels build up within the plumbing, eventually leading to a rupture. Leaving this appliance completely unmonitored creates a constant vulnerability. You are paying a premium for inefficient heating while simultaneously risking structural water damage to your home. The modern electric hybrid water heater was engineered as a departure from these traditional tank designs. Instead of relying on a single method for heating, a hybrid system integrates multiple technologies, utilizing a heat pump for efficiency, various operational modes for different demands, and internal sensors to detect moisture. Installing this system requires moving past basic pipe fitting. A proper setup must account for the thermodynamics of air temperature, the precise chemistry of interacting metals, and the integration of smart technology. Approaching the water heater as an engineered system enables the use of active structural protection and lower power operation. The system is called a hybrid because it splits the workload into two distinct capacities. Standard electrical heating elements sit at the bottom of the tank, reserved strictly for moments of high demand. But the primary work is done at the top, by the heat pump. This diagram shows how the top section operates. The heat pump pulls ambient heat from the air, while the electrical elements stay off. It takes the existing heat, compresses it, and moves it downward. Capturing existing heat requires a fraction of the energy of resistance heating. Relying on ambient air temperature reduces the amount of electricity the unit pulls from the grid, lowering the cost of generating hot water for your home. Because heat pumps actively pull warm moisture out of the air, they constantly generate condensation. That water has to be safely and continuously routed away from the unit. If you attach a clear plastic tubing directly to the condensation drain, you can visually inspect the line. If a clog starts to form, you can see the backup and clear it before the water reaches the system's internal sensors. You also have to manage the pressure inside the pipes. A thermal expansion tank is installed above the heater to act as a shock absorber, taking the impact of sudden pressure surges so the main plumbing doesn't have to. A high-efficiency machine processes heat and pressure at intense levels, requiring these specialized fail-safes to ensure it operates continuously without bursting a pipe or overflowing a drain pan. Beyond physics, you have to manage a hidden chemical threat during the installation, directly connecting standard copper household pipes to an iron water tank. This diagram illustrates electrolysis. When dissimilar metals like copper and iron make contact, electrons transfer, causing the iron to rapidly degrade. To block this, a dielectric union is installed. Its orange non-metallic insert physically separates the metals, completely halting the destructive erosion process. Even external chemistry matters. If an installer is careless and leaves excess soldering flux on the outside of the copper pipes, that acidic paste will accelerate green corrosion, eating through the metal from the outside in. A durable installation relies on managing the destructive chemistry happening where the metals meet. At the very base of the hybrid unit sits a bright red strip. This is the unit's active leak guard. If the tank fails and water hits the floor pan, this automated sensor instantly detects the wetness and completely cuts off the main water supply entering the heater. This active sensor provides a level of structural protection that traditional, passive tanks cannot offer. Once the physical plumbing and chemistry are handled, the homeowner gains control through the unit's digital interface and Wi-Fi integration. You can switch the unit into energy saver mode to prioritize the high-efficiency heat pump, or select vacation mode, which holds the water at a baseline 65 degrees while you are away. The onboard computer also logs an alarm history. If the condensation line clogs or the leak guard trips, the system pushes an alert to your phone, letting you address the issue before it causes damage. The digital tools provide visibility into energy usage and mechanical health, eliminating the out-of-sight, out-of-mind risk of older models. The modern water heater has evolved into a fusion of thermodynamics, chemistry, and digital tracking. By capturing heat from the air and blocking corrosion at the joints, the hybrid upgrade lowers utility costs, extends the life of the plumbing, and neutralizes the risk of flooding. A hybrid system provides the transparency and active protection required for a modern home's infrastructure.